Today I want to show you how to create your own trig functions so you can move them, stretch them however you'd like. To do that, there's a lot of different types of models that are out there, but here is my favorite. You have an equation, y equals something, times sine of 2 pi over something, x plus something. This is if you have to write an equation that's written in radian form. And this is the exact same type of model, but you put 360 here if you're working with degrees. And so the Khan Academy assignments that you're going to have they think in radians, so we're definitely using this 2 pi. Let me just tell you a little bit about what each of these different pieces mean. So A and T and M are going to be numbers that you're going to have to find that go into the equation. And so the A is the amplitude. And so as a reminder, the amplitude is the distance between, the height that is, between the midline and the highest it goes. And so that's generally a positive number if a curve starts increasing like this. It can be a negative number. You can put a negative something in there if you want your graph to start by going down instead of up. But the height between those is the amplitude, or A. The M that's here at the end is the midline. And so if this is centered around 0, then you would have nothing here at the end. But if the graph's been shifted up a little bit, then you would say +4 or something like that, whatever the height of the middle of the graph is. And then the middle part here, 2 pi is the normal period, the normal distance that it takes for a graph to do its full thing. But a lot of times the equations we're working with, we want them to take longer or go faster or something like that. And so this part that goes in front of x is always the normal period divided by the actual period. And remember, the period is the distance, the length that one cycle takes, which could be measured from the middle to the middle like this, or a lot of times it's easier to think about it as from a peak to a peak or something like that. But whatever that period is, that's what goes here. So let's look at a few examples. In this example, the equation says find the graph for a sinusoidal function. That just means it goes up and down curves. If it has a maximum point at 0, 7, and it intersects its midline at 3, 3. And so I'm going to think about what that graph looks like a moment. So it starts up high at 7, 0. Then it comes down and it meets its midline at 3, 3. And then as I continue, it must reach its lowest point and then go back up and eventually reach its maximum again. So the curve that I just traced out there is not a sine curve actually, but a cosine curve. And these models work just the same using cosine instead of sine. And so I want to use a cosine here. And they said specifically I have to write the formula when x is in radians. And so let's get rid of this guy. I don't need it. And so here's what my equation is going to eventually look like. I need to find a couple of pieces. I need the amplitude, the period, and the midline. And so I'm going to sketch a picture of that. Let me grab a cosine function a second. There we go. So here's a cosine curve, and let's label some of the points they gave us. They told us that its highest point was at 0, 7. And they said that it intersects its midline at 3, 3. And so another point here is 3, 3. Now, that means I know the height of the midline. The height of the midline has to be at a height of 3. And so I can fill in this m. That's got to be a 3. Now, the amplitude is the height that this graph goes up. Let me stretch this just so I have a little bit of room here. So this rises from 3 to 7, and this would be 4 steps down again, and then this would be 3 and then up to a height of 7. So that difference between 7 and 3 is the amplitude of 4. So we'll put a 4 here. Now the last piece I need is I need to know how long this was going to take to do its complete cycle. So what is its period? And for that, I'm looking at the x-coordinates. The first x-coordinate is 0. By the time I've reached the midline, I've gone 3 steps, and that is 1/4 of the way through the cycle. And so the period here is going to be 4 times 3, which is a 12. And so in here I can write 12, and this, Khan might accept this. You probably need to clean this up a little bit. The fraction 2 pi over 12 can be reduced, and so the 2 and the 12 can be reduced away to just pi and 6. So that's a final answer here. I will say I've seen a couple examples with Khan where you end up with a period that has a pi in the bottom, and so sometimes the pi's can cancel out, and you end up with something clean like 10 over 5x becomes 2. So you can have nice equations. This one wasn't so clean. It's got pi 6 in it. So anyway, you go there and you put that in. I'll show you how you type in the pi symbol a moment, because that may not be so obvious. So let's see, here we go. We would type in, I already forgot the answer, what was it? 4 times cosine of, and then there's a pi symbol right here. So pi divided by, I just did the slash bar, 6x. And then, what was it, plus 3? Better check and make sure. Yeah, plus 3. So let's see if we're right. Woohoo! All right, let's look at one other example. So in this example, we're still going to be building a formula. It's just they've given us our information a little bit differently. This is a application, if you will. And so I've got the person riding the Ferris wheel, Rania, I think, and we have her height off the ground is modeled, and they want us to use a cosine function. Notice this is the same shape, even though they have different letters. They used A for amplitude, they used D instead of M for midline. Doesn't matter, we're going to put a number there. And they abbreviated this part in the middle, 2 pi over T, as just B, but that's the equation we're going to use. So did they say it had to be in radians? Yeah, T should be in radians. So we'll get rid of this guy. And they want a cosine function. So I can do that. Oh no, got rid of way more than I wanted to. There. And so we need to find a couple of things. And so here's a cosine function. Let me just make it a little bit bigger so I got room. And we're going to have to peruse this and see if we can find some specific values for us. So it says at t equals 0, so t is our x-axis, if you will. When she starts moving, she's at a height of 10 meters off the ground, which is as low as she goes. And then after this many seconds, she reaches her highest point of 30. And so this graph is actually backwards from what I want. So I want this inverted 180 degrees. I want it to start low and end up high. The effect of that graphic or on our equation is that when we put in our A, instead of putting in a positive number, because we wanted that thing flipped, we have to put in a negative number. So I'm going to just remind myself of that and put a negative A in here a second. All right, let's find these points. They said that she starts at a height of 10 meters off the ground when time was 0. And she reaches her maximum height up here. That was a height of 30 meters, so y-coordinate of 30. And it happened at a time of 20 pi. And so that's our x-coordinate, or our t-coordinate, if you will. Pi. There we go. Sorry, that's going to be sloppy. I'm not sure if I can clean. Oh, all right, there we go. So none of these numbers are directly what I want here. What I really would like to know is what the midline is. That's m. And so the midline is going to be the height that's exactly halfway in between these heights. Thankfully, they're kind of nice numbers. So 10 and 30, halfway in between them is 20. And so the midline here is 20. And I can fill that part of our equation in. Now I need to know what the amplitude is. And the amplitude is the distance, the height, if you will, between maximum and mid, or between minimum and mid. They should be the same. And so to get from 10 to 20 is an increase of 10 meters. And to go from 20 to 30 is an increase of 10 meters. And so the amplitude is 10. And remember, it had to be inverted in order to cause this graph to start low and end high, because cosines usually start high and end low. So we are almost finished. We have just one more feature of this graph that we need to plug in, and that is t. And so the period, it's often abbreviated t because it usually stands for an amount of time, like it does in this case, is the time it takes to finish one whole cycle. So let me get a little bit of room in here. So now I don't care about the y coordinates anymore. I'm looking at the x coordinates. And so I start when time is 0. I'm halfway through my cycle when I reach my highest point at 20 pi. And so I need to do that again. And so I need to double 20 pi. So 20 pi times 2 is our period. That would be 40 pi. So here is a good first draft for an equation. It can be cleaned up a little bit because this fraction inside near the x can be simplified. The pi's can cancel out, and 2 divided by 40 would be 1/20th. And so let me abbreviate that a moment. And that should be a good final answer. Let's check it in Khan a second. So here it was this particular problem, and we had said -10 for an amplitude times a cosine. The frequency is what this is called, 1/20 times x. And then our midline was a height of 20, so plus 20. We'll see if we're good. Oh no, what did I do wrong? I thought that was what we had typed in. -10 times the cosine, 1/20x plus 20. What did they say? Get one more hint here. Oh, you got to be kidding me. Of course, it's a function in terms of time and not x. I had everything else right. Oh, well, that's why you watch the videos and you see how to do them and learn the mistakes from Mr. Rohr so you don't have to make them yourself. Anyway, I hope that helps a little bit. Feel free to try these a couple times if you will, and I would definitely sketch out a picture like that. A piece of scrap paper to make that happen should go well, and hopefully you won't have the same mistakes I do. All right, love you guys. Hope you have a wonderful rest of your day, and I will see you in the next video.